All right, here we go now. All right, so multiplication of polynomials is what we're going to be talking about in today's edition of Driving Math with Mr. Glenn. Don't forget to hit the notification button. Don't forget to hit the subscribe tab and comment, like, share, all that jazz. So here we go. So we are going to multiply this information. We're distributing the 2d squared. So 2 times 6 is 12. D squared times d squared is d to the 4th. Then 2 times 5 is positive 10. D squared times d is d to the 3rd. Because remember, we're multiplying the exponent. We're multiplying with the same basis, so we add the exponents. And then 2 times negative 3 is negative 6. And d squared times 1 is d squared. So that is your answer. All right. So then we are multiplying a binomial times a trinomial. So what I like to do is to draw a 2 by 3 box. It's not perfection. But here we go. All right, so we're going to write a squared 5 2a to the 3rd plus a minus 9. And then we're going to, you know how you use multiplication table? We're going to use the multiplication table. They call this an area model because you're multiplying, you're trying to find out what this number is. So you have 2 times 1, 2, a squared times a to the 3rd is a to the 5th. And a to the 2nd times a to the 3rd, a squared times negative 9a squared. 2 times 5 is 10, then a to the 3rd. 5 times a is 5a, and then 5 times negative 9 is negative 45. All right, so if you have a baby in the background, apologize for that. That's my newborn. She's like 7 weeks old, and she likes to be upset sometimes. Okay, so we're going to add things that are alike. So 2a to the 5th. Okay, then we have, did I miss it? No. Then 10a to the 3rd plus a to the 3rd. That gives you 11a to the 3rd. Then you have negative 9a squared, and then plus 5a, then minus 45. So that is your answer when we're multiplying a binomial times a trinomial. Now there is another way to work multiplication. You can use multiplication of binomials, and you can use FOIL method. Okay. Now in the FOIL method, you can only use a FOIL method with binomials. Binomials are 2 terms. All right. So it's going to be first. All right. So that's 2v times 3v is 6v squared. And then outer, okay, 2v times 5 is 10v, and then inner, the 2 inner terms, that's 27v, and then the 2 last terms, that gives you 45. Then you add or combine like terms, so you have 6v squared, 10v, that's plus 27v is 30. 10v plus 27v is 37v plus 45. And that's your answer. Okay. Now let's see if we can add to this information. Okay. So one way to add to this information is what they call product of squares. Okay. All right. Product of sum and difference. difference of two terms. So for example, if I have v minus 9 and v plus 9, okay, I know I can use the box model or the area model, but I can also say, okay, first n is v squared, outer 9v or plus 9v, then minus 9v because of the inner, and then the last would be negative 81. But as you can see, this middle term is going to cancel out. So your answer is going to be v squared minus 81. So when you have the same first terms and the same last terms, but different operation, all you're doing is squaring the first term, and then it's minus the square of the last term. Okay, and that is your answer. Okay. All right. So from there, we're going to solve if we were to expand. So that's the product of sum and difference of two terms, of two binomials, in fact. Okay, we're still multiplying polynomials. I just need a little more space. All right. All right. So we're going to solve something like 3/5 t minus plus u times 3/5 t minus u. So you square the first one, which is 9 over 25 t squared, minus the square of the last term. So that would be your answer. Okay. If we needed to expand it, in the sense of, if I said q plus 2, q plus 2, we can still do the same FOIL method. Okay, the FOIL method would say first, outer, inner, last. Okay, and you would get q squared plus 4q plus 4. That will be your answer. Now there is a shortcut to that. So if I wrote q plus 2 squared, I could write it out like this, or I could just say I'm going to square the last two terms. I'm going to do q to the second and then 2 to the second, which is 4, and then I'm going to multiply 2 times q, which is 2q, and then multiply that times 2, and that gives us 4q. Okay, and as you see, you have your answer here. All right. All right, another example would be I'm going to square the g, square the 10, right? And then I'm going to have, that's a positive 10, because square 10 is a positive 100. Then I'm going to multiply 10 times g, right? 10 times g, right? Or negative g, or negative 10 times g, and then times 2. That gives you negative 20g. And this is your answer. Okay, so if we had a larger exponent, if we had a larger exponent binomial, we would simply say, okay, now a plus 4 to the second times a plus 4, or times a plus 4, right? And so I would go a squared, right? 4 times a is 4a. 4a times 2 is 8a. And then 4 squared is 16. And I'm going to multiply that to a plus 4. Remember, there's a trinomial times a binomial. And so what I'm going to do is the box model. So it's going to be a 3 by 2 or a 2 by 3. So a squared, 8a, 16, and then a plus 4. And then I solve it. This is a to the third. This is 8a squared. This is 16a. This is 4a squared. This is 32a. And then 16 times 4 is 64. So then we add, we combine instead of add. Combine like terms, right? That's 8 plus 4 is 12. The bases are the same, so they stay the same. 32a plus 16a, I believe that is 48a, and then you have plus plus 64, which is your answer. All right, so that's how you solve this particular problem if your exponent is a little larger than 2. All right, if it was 4, you would do the exact same thing. All right, so thank you so much for tuning in. I really appreciate it. And then here's another example. I remember working a problem like this, and I was just really dumbfounded by how to solve it. Okay. Let's see. Because I was in class working this problem and trying to figure out how they solved it. Okay, I'm gonna have to pick this up. I apologize. I can't see. Okay, as you can see, it's the exact same terms. The only thing that's different are the exponents. So this would be considered your A, this is your B, A. So this is your A plus B, and this is your A minus B. Okay, so it happens that we gotta square this. So we're gonna square the last two terms. So we're gonna do 3C plus D, we're gonna square it. Okay, and that's the first thing we're gonna do. So we're gonna square it. That's 9, because 3 squared is 9. Then C squared, and then D times C, CD. So you get 3CD times 2 is 6CD, and then you square the D. Okay. All right. That's what you get from there. Then you square the last term. Okay. You square the last term, which is going to be 4, right? That's 4n squared. Now that middle term is what's kind of confusing to most people. you have minus so there's and then minus 4n squared, and there's your answer. Because the middle term is going to be absent, right, because they're opposite, the only thing that you actually need is to square the first term and square the last term. That's why this is your answer. And there's no what is it? Middle term cancels out. Okay? And that's how you solve your problem. Sorry, I had to look at my notes. I forgot just in that moment, and I apologize for that. That happens sometimes. So make sure you go back and look at your notes if you don't remember something. So there's a word to the wise. This is raw footage, people. Okay. Once again, thank you for driving math with Mr. Glenn, and please subscribe, comment, share, like the video. Let us know what it is that we need to do better, specifically me. All right. You have a good one. Bye. See you later.